going to squat down a little bit. Today, so just to start, my name is Eric Sammer. I'm one of the engineering managers at Cloudera. I run two of the teams within Cloudera's engineering group, one of which is building the Clutter Development Kit, or the CDK, which is what I'm going to talk about tonight. Before I sort of dive into that, this is a quote that came out of one of the gentlemen I know, this guy Arun Jacob, who runs Disney's internal data platform team. It was an interesting quote. It was, it's not enough to build a scalable and stable system. The system also has to be easy enough for thousands of internal developers and to be able to use. And I think that this is something that we've had the sort of dubious honor of seeing at Cloudera. Cloudera has a couple hundred different customers and different verticals and things like that. And one of the things that we see a lot is different skill levels for different developers coming from different backgrounds. Lots of sort of standard Java middleware developers. I think a lot of the same people that Terrence was talking about earlier that might not be sort of deep distributed systems people or data management people, but might be people who know things like Spring and Tomcat and sort of like traditional JMS and Java middleware. So we really wanted to make this entire platform, Hadoop and all of its related ecosystem components, a little bit more accessible to the sort of standard enterprise Java community. So I think when we look at it, we say, like, sure, Hadoop is really powerful, lets you work with all the different file formats. Now with things like Yarn, systems like application development kits like Weave, you can build all these sort of newfangled data-oriented or distributed applications. And in a lot of ways, Hadoop is really, really flexible. It lets you get away with all kinds of different things, just as a side effect of the different sort of abstractions that it gives you. Unfortunately, what we've seen is that Hadoop is also really low level. For a lot of people who have written, and just by show of hands, how many of you have written a MapReduce job using the plain Jane Java MapReduce APIs? Yeah, so it's enough hands that go up, and they kind of go up with that sort of post-traumatic stress disorder, like, yes, I've survived this. It was terrible, but I did it, and all I got was this T-shirt type of thing. So to even implement the simplest things of like a relational join or basic filtering application, this stuff is pretty low level, and I don't think that I'm breaking any truths by talking about that. And as a result, and much like everything that Terrence just described, Hadoop is incredibly complex. As a side effect of being a distributed system, it's much harder to build a quote-unquote Hadoop application or a data pipeline or a back-end distributed system on top of Hadoop than it is to build a system on MySQL, right? It's just, by definition, more complex with all of these different moving parts. So this is my eye chart. We're going to start here. I think when most people talk about like the typical application or the typical system that people build on top of Hadoop, it's very commonly, and most of you probably can't see this, which is kind of the point, is that when an architect stands up at a whiteboard and says, we're going to build a Hadoop application, it's going to be great, and don't worry about it, life is going to be good. This is kind of what they draw on the whiteboard. They say, there's going to be a web application, and that web application is going to spit out a bunch of events, like user activity data, or click transactions, metric information, application performance metric information, things like that. We're going to take that event data, and we're going to collect it into a big bucket called event data. And then we're going to run like maybe an hourly job or a job that runs every 15 minutes where we calculate some billing information. And we're going to build a reporting data set that we use to drive a relational database system or business intelligence application or build recommendations. And this is the application. Dear Java developers, go build it, right? But when you think about it, it's a little bit more involved, right? When you look at that web application, you've got the servlet, and then you've got this log4j appender or an SLF for J appender, and you got to figure out how you're actually going to transport that event data from that web application into the repository of like where these events eventually need to land. And in the world of Hadoop, and I assume that most of you care about Hadoop, that's probably a file system like HDFS. And you might look at a system like Flume. I'm a little bit biased. I'm one of the Flume committers. But it could be Kafka. It could be whatever makes the most sense to you. You got to figure out how all of that works and transport events over into HDFS. Then you got to worry about the MapReduce layer and building that sort of job that's going to run once an hour every 15 minutes or whatever it is. You then need to, maybe you pick SQL and you say, I'm a SQL developer, I'm going to use Hive to author my MapReduce jobs because I have PTSD from writing MapReduce jobs by hand. So you decide you're going to do that. And then you say, well, now I need a scheduler or a workflow engine to drive this to make sure that it runs every hour or every 15 minutes. So you've got like all of these different pieces. And that's sort of the next layer of like zooming into the system. But of course, that's not it either, right? So that's what the typical Java developer writes out in their sort of design doc or whatever. But when you get into the nuts and bolts of the system, what you realize is, well, you actually need to worry about the structure of the events that you're going to log. Or am I going to use text records and worry about parsing them down the road when I get them into HDFS? Or am I going to use a structured format like, God help us, JSON, or Avro, or Thrift, or protocol buffers? Then how do I make Flume understand my Avro format events? How do I deal with things like file durability or delivery durability? How do I get that data partitioned? Maybe I want to partition that data set because it's too big in HDFS. You just sort of keep ballooning out as you zoom into these systems. And at the end of the day, the only part you really care about, and the only part that your company really cares about, is getting the data from A to B, probably in the right format, and using it later. Everything else is just in between you and your paycheck or you and your Caltrain home, whatever it is. But you have these serialization, file format problems. What compression codec are you going to use? Metadata capture and maintenance of it. You have all these sort of things that I wouldn't say this back at Clutter's home office, but the relational database community has figured this out for the last 30 years, right? You need schema evolution, you need metadata tracking, you need administrative tools for managing that, you need partitioning, you need compression, you need the proper on-disk format, yada, yada, yada. So all of these, and then you've got sort of the distributed systems aspect. You've got the delivery mechanics, the failure mechanics, the data durability semantics, failure semantics, and sort of how things break down. You almost certainly want performance and health instrumentation of all these different components. It's a lot to think about, and it's a lot to worry about. So we looked at this and we said, at the end of the day, this is the difference between the toy application that Terrence talked about, like all this stuff, sorry, I don't mean to imply Terrence is talking strictly about toy applications. What I mean is that when we're referring to a toy application, sort of your Hadoop 101, I can get a text record from a web app into HDFS. That's like the first 10% of what you need to do. The other 90% is all the mechanics that surround that, right? So the production sort of beefing up of failure scenarios and all this other stuff that Terrence was describing in the Yarn world also applies sort of at the macro level, all these different services. So we look at this and we kind of say, as Cloudera, this is the thing that prevents you from adopting Hadoop as a platform. And quite frankly, that cuts into our bottom line. We don't like that, right? We want Hadoop to be easy to use, easy to build these sort of large-scale, data-oriented applications on top of. So this is also sort of self-serving in the sense that we have a field technical services of 100+ people that do this over and over and over again for various customers. So what we really wanted to do is build a kit of various libraries and APIs that make these types of applications a little bit easier to do. And it's worth stating, since Terrence just gave this sort of really cool presentation around Weave and what Continuity is doing on Yarn, it's worth pointing out that everything I'm going to talk about is mostly on the data management and ingest and sort of management side. It's completely compatible if you wanted to use something like Weave on the compute side. So we're not really tackling the compute problem because we know that other people are. So what we decided to do is to make these APIs and really take a lot of the expertise and the sort of expert patterns for distributed systems, for data management, and sort of bake them into code as much as possible behind some really simple, sort of easy to use APIs. So you'll see a lot of similarity in what I'm describing for this problem domain as what Terrence described on the Yarn side. We really wanted to make the quote unquote right thing easy to do. So we know, for instance, that 90% of the people that write data into Hadoop do it in text format and then regret, like 100% regret it later. You know, nobody wants that at the end of the day. It's really big. It's just a nightmare to deal with. You get into compression codecs that these ones are splittable and that's not splittable, and there's RC file and there's Parque and there's Avro and there's protobuf and there's all this other stuff. And most people go like, I really don't care. I just want to get data into HDFS and query it via Hive or Impala or process it with my new fancy Weave application. You know, most people don't care about this stuff. So we really wanted to make the right thing easy to do and just obvious. We wanted to be the default. We wanted to fix the defaults, if you will. And we really wanted to focus on the most common use cases. And I'll use this ingest like event data into a big bucket, process it, refine it into a different, smaller bucket, then you serve it downstream with other systems. We really wanted you guys to be able to focus on the application logic. And I want to focus on the application logic. You know, unfortunately, Cloudera pays me to do the infrastructure work. So, so that's what I'm stuck with. It's not really a bad gig. We're hiring as well. So it could be your bad gig as well. Well, I got to entertain myself as well up here. I give this presentation all the time. So, and much like, you know, J2EE, and that's probably a dirty word for some of you and your lifeblood for the other half of you, you know, J2EE, especially servlets, took apart these two things, right? You don't want to worry about multi-threaded development and HTTP as a protocol and, you know, all the various other, you know, request response mechanics and deployment. You really want to build the little 5 lines of code that you actually need to do to serve like a velocity template or something like that. So that's really where we sort of want to be. So the Clutter Development Kit, or the CDK, because I'll get tired of calling it the Clutter Development Kit really fast, is an open source set of libraries. It's Apache license, so it's completely compatible with the rest of the Hadoop ecosystem. It's up on GitHub. I'll give you some pointers later. And it's really a set of libraries, guides, examples for building these sort of data-oriented, distributed systems-oriented applications. And it definitely and completely builds on existing APIs that, in my world, that's CDH, rather than replacing. So like Terrence said, you know, Weave doesn't replace Yarn. The CDK doesn't replace HDFS, MapReduce, Flume, Kafka, any of these other things. It's a thin veneer on top of that to make life a little bit easier. We really wanted to focus on this notion of piecemeal adoption because not everybody uses HBase. We don't want to force HBase on you. Not everybody wants Hive. We're not going to force Hive on you. So we want you to be able to pick and choose the parts that you like and make sense for your application. So we set out to build like a set of modules, for lack of a better thing to call them. And each module is sort of a self-contained set of APIs that kind of work together for some specific problem domain. The first thing that I always jump up and down about and scream and yell about is getting data into Hadoop in the right way. And there kind of is a right way. And yes, you can do text and you have that flexibility, and we're not going to take that away from you. That said, it's almost certainly not what you want. You almost certainly care about things about like partitioning, compression, metadata management, all these other things I was talking about earlier. So the first module we built, we just called very charmingly the data module. And really what this is a set of APIs for interacting with logical data sets in HDFS. So if you're using HDFS, we wanted to give you a higher level construct than files and directories, because really, like the relational database wraps all of this other information around the notion of a table. It has schema, it has evolution semantics, it has various guarantees in terms of how it works. We wanted to give you the same thing on top of HDFS. We really wanted things like file format, partitioning information, and schema management to be configuration driven rather than code driven. We don't want people sort of manipulating the low-level bits. We want people worrying about sort of higher level logical abstractions. We wanted to give a consistent data model that all of the tools would understand and be compatible with, so that you don't have to say, well, Hive supports RC file, but Pig doesn't. And if I use hcatalog, well, then maybe this other thing. None of that matters to you. Nobody cares about that. I mean, we care about that. We want to care about that for you. Keeping track of things like metadata integration with either third-party systems or sort of de facto standards that are cropping up in the Hadoop world, like hcatalog is one of those standards. You might not care about hcatalog specifically. You might not know what it's called, but I'll guarantee you want its functionality. So we want to give that to you for free, wherever we can. And like I said, things like partitioning and management of that, we really wanted to make that as simple as possible. So in the interest of showing you, some of the meat behind it, again, you'll see a lot of the similar sort of fluent builder-oriented APIs that are a little bit easier to deal with. So on the left here, I have an example of using the data module APIs to create and write a bunch of events to a partitioned data set. On the right, I have the result that will materialize on HDFS. There's a couple of things that we've done here that are particularly tricky. One, we make sure that the partitioning is the partition format that's going to work with Hive, Impala, and everything else that understands sort of that Hadoop de facto partitioning scheme. We work with a file format and sort of abstract the nuts and bolts that's going to work for 90% of your use cases. And if you're smarter, then by all means use the trapdoor and sort of build your own sort of format plugin. But in reality, the defaults are the right thing for most of you. And yes, all data is compressed all the time. What if I don't want it compressed? Then you can dig into the trapdoor, but most of the time you do. So it's that way by default. So up at the top, we have this notion of a dataset repository, which is a slightly different name for a database. It's a collection of data sets that all sort of generally you want to live together or have the same attributes or the same usage patterns. There's a plugin that specifically understands HDFS and the local file system called the File System Dataset Repository. And again, it's got a nice builder. And basically the way it works is that you supply a Hadoop file system implementation, and we handle all of the guts around laying data out in that file system for you. You just give us a root directory, and we sort of take over from there. The same way HBase, you give it a root directory, and it takes over from there. So in this case, we're using the root directory /data for no other good reason than it was easy to type. From that dataset repository, we create data sets. And when you create a data set, you give it a name, and you give it a dataset descriptor. And that descriptor specifies things like the partition strategy, which again has a nice builder. You can do things like hash partitioning or identity partitioning, range partitioning, whatever makes most sense. And we define all schemas in terms of Avro schemas. The on-disk representation might not be Avro, but we give you one schema definition language. And we handle what that materializes to be on the file system, because, again, for lack of a better alternative, Avro has reasonable APIs for describing schemas. And we were able to, we had a committer who's on the CDK team who kind of went like, hey, we can get better fixes into Avro, so we did that. Once you have a data set in hand, this is the equivalent of a table. All records in that data set will sort of look the same. They'll have the same schema. And that schema can be as simple as it's got one field and it's called text, and it's just a big string. Or it can be as complex as a binary array that represents a JPEG image, automatically compressed, automatically accessible via MapReduce, and all this other stuff. From this, we let you create and grab a handle to a writer, and you simply write Avro records. Again, in memory, we always describe these things as Avro. well, actually, you have your options. They're either Java POJOs, an Avro generic record, or a generated Avro class. Under the hood, we do the right serialization. And you can just, here I'm showing a generic Avro generic record. You pack your data into it. You flush the writer however you want, and you close it. On the right-hand side, you see the resultant data that would materialize on HDFS. We don't show it here, but there are different what we call metadata providers that let you plug into different metadata systems. And that can be things like hcatalog, or it can be, in this case, we actually just store the metadata on the file system alongside the data set in a hidden directory. So we serialize the descriptor properties and the actual original Avro schema so that when we load that data set, you don't have to provide us the Avro schema. We can load it from the metadata provider. And if that metadata provider is hcatalog, which is purely a configuration problem, all of the data sets you read and write using these APIs are immediately available to Hive and tools that understand the Hive metastore, including Impala, which Cloudera users care a lot about. So this lets you do sort of really fancy things where you can write data and switch terminals and immediately query it, which is really, really nice. So we handle partitioning, and again, if you've used Hive and you understand Hive's partitioning model, this makes a lot of sense to you. Although I don't know that you ever want to partition by hash of user ID, but there's a good example. One of the other modules, so that's the data APIs. It's just sort of a whirlwind tour. And what you'll find is one of the things that we do with these APIs is we know that nobody reads documentation. So let's just be serious about it. Like, no one reads it. I wrote the APIs and the docs, and I never read them. So one thing that we realized is that developers, the documentation they use is the autocomplete in their IDE. Like, you type a dot, and whatever the next set of methods that appear, those are the ones you call, right? So we really wanted that level of accessibility to some of these APIs. So if you're like me and you can't be bothered switching to your web browser to look at the docs, we sort of abide by this IDE autocomplete documentation. One of the other modules that we built was a system called Morphlines. It's just a library. And really what it is it's pluggable, configuration-driven, record-level transformation. So if you have a stream of records that you simply need to rip apart and reformat from various formats and apply various processing to, Morphlines is your thing. This actually came out of Cloudera Search. So Cloudera recently added search to our repertoire, which is Solr with some nuts and bolts packed onto it. And one of the use cases that everybody wants in search is that they have a stream of data coming in from Scribe or Flume or Kafka or whatever. And as records arrive, you want to shove them into Solr in real time so that they're immediately queryable by the search system. And maybe you want to send another copy to HDFS for analysis or transformation. But what we found was that people were getting text records in, but they really knew that they wanted to tear that record apart and extract the date. And they wanted to extract the severity of the log message. And they wanted to do this sort of inline transformation. So Morphlines was exactly that. And what the search guys had done was they embedded it inside of Flume so that as events were passing through Flume during data collection, they could be sort of torn apart in real time and indexed as sort of higher order events. So that's what Morphlines is really built for. We realized that this was useful in many other cases, not just the Cloudera search case, so we decided to make it a library. For users of things like Logstash or Splunk, this probably sounds pretty familiar. So you can configure these transformation stages, and you have this sort of container. If you're familiar with like a chain of responsibility pattern, that's basically all Morphlines is. You can use this as a library inside of Flume, MapReduce jobs, Storm, any other Weave applications, doesn't matter. You can embed it wherever you want. And plain old Java applications that are totally unrelated to this particular platform. There's a bunch of other modules, and I don't have time to go into all of them. We built like a Maven plugin, which lets you do sort of automatic packaging of your quote-unquote big data applications, deployment to HDFS, and sort of the ability to execute these processing pipelines. We also give you the ability to do sort of, for Rails users, they're used to having things like data migrations, where part of the build actually migrates, the schema over time. We give you the ability to do that with CDK datasets. There's also a huge module full of examples, just various examples that you can take, customize, use outright, do whatever you want with. Things like taking POJOs, generic records, and generated entities or records or events, and just ingesting them to Hadoop in various ways, partition, non-partition, so on and so forth. Dataset administrative operations, so if you want to build sort of custom tooling around schema, viewing, and stuff like that. We have crunch and MapReduce integration with all these data sets and various other pieces of the platform. We realize that this is sort of the tip of the iceberg, and really our goal is to build out sort of this real rich, high-level, easy-to-use set of APIs. There's a lot of stuff I didn't talk about. Obviously, HBase is a huge topic. We're actually in the process right now of integrating sort of a really nice HBase layer that has all of the right schema evolution stuff on top of it, that is compatible with HBase's flexible schema model, that handles row key sorting in the right way if you don't want to deal with mem comparable, lexicographic sort order and all this other nonsense, and all those other sort of higher level features. We want to do a bunch of stuff with higher order data management. You can think about common tasks that you have to do with data sets. Things like background compaction of many, many files, or automatic file format conversion, or background conversion, things like that. We might do things like libraries for data set exclusive read, shared, and exclusive locks for data in HDFS, because sometimes you do want to actually lock data sets. So we would build like the Hadoop equivalent of flock, for those of you who are familiar with that. Integration with existing middleware frameworks. So there's systems out there like Spring Batch and Pentaho and all these other things that you might also use. But by all means, please give us your good ideas. You can keep the bad ones, but please give us your good ideas as well as your code. So if you want to sort of get started, again, just like Weave, this is available on GitHub. It's Apache licensed. You can take it and do whatever you want with it. So github.com/Cloudera/CDK. There's also a CDK-examples repo that you can take and do all sorts of fun and exciting stuff with. We also have binary source and documentation artifacts in Cloudera's Maven repo. So if you use CDH, you go in and you create a Maven dependency, and you automatically get all the right stuff. There's community.cloudera.com that has forums. People like me and other folks on the CDK team will be answering questions. There's a mailing list if you prefer email. If you don't have enough email, we can add to that pile for you. Or if you want to file JIRAs and tell us we got it wrong, please feel free to do that. And with that, I'm happy to take questions that people have. Yeah.
How does the CDK abstraction which you are providing for partitioning data and all of that fits into Flume?
Oh, it's a good question. So the question is, how does this sort of the dataset partitioning stuff fit into Flume?
Right. Flume already provides that.
Right. So Flume provides very basic understanding, and it's mostly the same thing, right? It's mostly Flume's bucketing support, which is what we called it in Flume. It's the ability to inspect an individual record, extract a couple of pieces from that, and then decide to parameterize the file system and lay it out the right way. So basically, there's a little slice of Flume that I've always wanted to be able to use in different applications. So this dataset API is actually like a slice of that lifted out of Flume and made into a nicer API. There's a couple of other things that Flume does under the hood that are kind of specific to Flume, and a couple of things it doesn't do that you probably want it to do if you were to use its partitioning support outside of Flume itself. So Flume doesn't actually have any knowledge of structured events. It has like a key value pair map of headers, and then a binary blob is its body. And you have to do a bunch of trickery to extract pieces of the event into the headers before you can do bucketing. In reality, what this is a cleaner way to do a lot of that. And Flume only supports like identity partitioning, so taking an exact value out of the header and plug it into the path. What we found is that people wanted to do fancier things like apply this function to a field to get a value and then partition by that value, which is basically like hash partitioning and stuff like that. So if you wanted to do ranges or any sort of complex partitioning scheme, you kind of have to do some funky stuff. So that part is much easier. There's also mechanics around the durability. Like Flume very specifically is managing file handles. And in this case, we want to give you the ability to handle, well, actually under the hood, we handle things like how many file handles do you keep open while you're sort of binning data and recycling those file handles and doing all the magic that, for better or worse, we need to do because of the HDFS append-only semantics. Yeah. Yeah.
Are you thinking of developing a sync to utilize this factory?
Yeah, that's a great question. So the follow-up question, of course, is why don't we just build a Flume sync that sort of wraps the dataset APIs and sort of does the right thing and gives you this? The short answer is it's absolutely a Jira that's sitting on my to-do list. Today, if you look at the examples, what we do is we line up the partition scheme and Flume's bucketing to be identical and sort of make sure that they line up. Because at least today, it's possible to get it wrong. And I don't like that, right? Because people will, right? And people do. They get everything wrong. There's also like stuff like, what do you do if Flume is missing the header? Like Avro actually gives you reasonable support about defaults and unions and all this other stuff. So yeah. Yep.
I had a question.
Sure.
So in this SDK, are you exposing Cloudera Manager APIs?
Good question. So are we exposing Cloudera Manager APIs in this? The short answer is no, and I'm going to tell you a dirty secret. No one's allowed to repeat it outside of this room. Nothing in the CDK today is Cloudera specific, and that's very much by design, at least for today. We don't want anything to require you be running Cloudera Manager, at least not today. So if you just run CDH, or, and I don't know why you would, if you run some other Hadoop distribution, I don't test the latter, but there's a good chance it just works. So there's no Cloudera specific stuff in it. In fact, we're thinking of renaming it specifically for that to sort of indicate to the world that it's not just Cloudera. That said, the Cloudera Manager team has actually built some reasonable Java APIs on top of the Cloudera Manager, the CM API, that make life a little bit easier. There's actually another Git repo if you sort of poke around under the Cloudera space there on GitHub where you'll find that. So I don't know that we'll never do it, but if there were a reason, because this is like the Cloudera Manager is like almost exclusively for the operations folks, like the DevOps guys and stuff like that. This is almost exclusively for the, I build servlets, I build data applications, I build, data pipelines. Community, they tend to be different. If they weren't different, I don't know, maybe we merge them at some point.
Even if you expose the APIs, then Amazon might want to support the Cloudera distribution.
Yes, so I'm not going to repeat the question because the short answer is that there's always stuff going on with Cloudera as a company. Tonight, I kind of have, at least while I'm up here, my Cloudera salesman hat off. And I'm happy to talk about that stuff offline, but I really want to just focus on the developer stuff up here. Yeah?
Do we use this SDK inside Cloudera for different applications?
Oh, do we actually use the CDK? Yeah, absolutely. So we eat our own dog food very much on a lot of this stuff. So if you're like a paying Cloudera customer and you've paid for like professional services, it might not be called the CDK. It might be called com.myawesomecompany, but these APIs and this code may actually be in use at various places. So it is actually used in a number of different places, and we're talking to a number of these other sort of non-Hadoop ecosystem specific framework guys, and I won't name names because nothing's final, about using this as their Hadoop integration support. So you might see this appear in various other places. The CDK as a project is relatively young. We started it in like March of this year. Well, that's when the first release was. It was started before that. And we're doing monthly releases right now. So we're actually moving very, very quickly. So things are changing very, very quickly. Not on the APIs, but just on like the scope of the project, the people who are interested in it. Certainly, we use it very much internally. There's a bunch of our customers that already use it in various ways. And we've actually started getting like community pull requests on GitHub from people we've never heard of, which I think is a good sign, right? People just randomly going like, here's this thing I did, and you have no idea who I am, and please take it. Once we work out the licensing, we pull that in. So we're happy to take contributions that way as well. So the short answer is yes. There's one customer in particular that processes a couple terabytes per hour that pass through the CDK. Any other questions in the back?
Hi. This is regarding the Avro thing, the utility that you use.
Yeah.
You did mention that it is exposed to the outside world as Avro interface, but internally you are storing in some other format.
Yeah, so by default, it's that we actually store in Avro. Because we care very much about Impala, as a side effect, we care very much about Parque, which is a new columnar format that Cloudera and Twitter and a couple other people have been sort of collaborating on. Also open source. It's a columnar format. We can talk about the difference between row and columnar and all that stuff. But there's actually a flag that you pass when you create a data set in a data set descriptor, and you say, I want my data in Parque, to be sort of easily queryable or more performant under Impala. And your application still uses Avro in memory, and then on disk we actually write Parque data the right way. We're talking about, and I'm reluctant to do it, I'd really love to hear people's opinions on it, about whether or not we actually support fully support text as an underlying format. I am reluctant to make it any easier for people to write new text data into Hadoop, but I recognize that people already have text data in Hadoop. So it's not an option that we expose today. It's easily done, but so today it's just Avro and Parque.
Interesting. My follow-up question is, the Avro provides two advantages. One is the schema, which goes with entire data, and the other one is version. Right? So when you transform to some internal format, how are you dealing with those?
So we actually maintain the data in memory completely until it's actually serialized. So it stays in Avro format until it actually winds up being Avro on disk, where there's zero copy. If you're using a generated record, or in the case of Parque, there's a copy to Parque's internal format. But you can represent almost every other schema structure with Avro's schema language. Everything else is a subset, because Avro supports all kinds of wacky stuff. In reality, you can support the sort of relational subset of columns and rows and types, and then sort of default, columns with defaults and the ability to modify that schema. So, at the end of the day, everything winds up being a subset of Avro's sort of description of a data set. So it's pretty easy to convert that under the hood. I don't know if that's actually an answer to the question you asked or my interpretation, but close enough? All right, good enough. Close enough is excellent. It's a good place to be.
Okay, any more questions?
Cool. Thank you
All right,
guys so
thank you.
much.